Hello friends, welcome to your channel harugeomatics. Today we will study second part of the data structure, which is known as the non-topological data structure. As we have studied in previous lecture, that is topological data structure, which have the special relationship between the different features or data. But in case of non-topological data structure, there is no any linkages and there may be a repetitive uh, storage of data. Means uh, one data can be stored twice in the database. As we consider like two polygons which are linked with each other, so in topological data structure there may be one line that will connect to both, or that is common for both polygons. But in case of non-topological data structure storage, both polygons will be stored separately. So that common line will be stored twice to represent both polygons. But in case of topological, it will be stored only once. So non-topological data structure is a type of vector data structure. So and these type of data structure are also very common in GIS softwares like CAD, computer aided design data structure, and such formats like drawing exchange format DXF, which is used in CAD package. Example AutoCAD for transferring of data files. So it is an example of non-topological data structure. DXF does not support topology and arrange the data as individual layers. Means they did not connect two polygons with each other, A polygon or B polygon. So these polygons in the CAD format, these polygons are stored separately, and this common line are also stored twice in case of non-topological data structure. So one layer will store A polygon and another polygon B will also be stored separately. So this structure consists of listing elements, not features. Means we have to uh, calculate how many elements are there. So they are stored in the form of listing elements, not features. So every element are stored separately. But in case of topological, no, there is no any repetitive data. So non-topological data structure consists of listing elements, not features, defined by strings of vertices to define geographic features. So all the geographic features are stored in the form of point, line and areas or polygons, but they are stored separately and they are not linked with each other. Means there is no any special relationship in this data structure format. There may be redundancy, like some boundary segments that are common between two polygons, they are stored twice, once for each feature or once for each polygon, as we have seen in the diagram. Like two polygons are connected with each other, so the common line is also stored twice for each polygon. So this format allows users to draw each layer by using different line symbols, colors and text. So as we have stored polygons as a separate layer, so if we want to change color, symbol or text any of the layer, so it can be easily converted, and it is useful for us that we can convert uh, or draw any layer wise symbol, color or text. So it is also helpful for us. As in non-topological data structure, there is no any relationship between each other. So polygons are independent and difficult to answer about the agency of the features. Means we cannot differentiate or calculate the agency of the polygon feature because they are stored separately and they have no any relationship between each other. The CAD vector data model lacks the definition of a special relationship between feature that is defined by the topological data model, as we know already. Since 1990, almost all commercial GIS packages such as ArcGIS, means these non-topological data structure are also used in many important ArcGIS applications like ArcGIS, MapInfo, GeoMedia. They have adopted non-topological data structure. Why? Because they have some application and advantages over the topological data structure. We can uh, draw each layer by using different line symbols, colors, and text, and it is also useful for the quick display on the system. Means they have any no link, they don't have any linkages between the data, so they can be displayed quickly and they can be saved layer wise. So for example, these software or applications have a non-topological data structure, and there is a .shp shapefile, standard non-topological data format, which are very useful and common useful data format used in the GIS packages. If you have used ArcMap 10.1, I have used that, and I have also created many shapefiles and processed them to get out to find the results. So shapefile is a very common data format, and it is an example of non-topological data format which are used in many GIS packages. In ArcInfo coverages, the geometry of shapefile is stored in two extension types. Means shapefile have to be stored in two extension type. First one is the .shp, second one is the .shx, and there is a difference between these two shapefile data extension type. First one is .shp shapefile store the feature geometry. Means any geometry of any feature or any object are stored in the form of .shp means shapefile, and .shx file maintains the spatial index of the feature geometry. So any object, the geometric information are stored in the .shp, and along with the shape feature geometry, spatial index are also stored in .shx format. So we have to differentiate these two extension type of the shapefile. First one .shp store the feature geometry, and second one .shx file maintain the spatial index of the feature geometry. Means about the coordinate information of the feature or object. So what is the advantage of non-topological data structure? Because uh, shapefiles lies in quick display on the system than the topological data, because they have no any special relationship and they don't have to run that operation. They don't have run to find the relationship between the data, so they can be quickly display on the system. So it is a very useful, and we can second advantage is what, that we can draw each layer by using different symbols, colors, and text. It is also an advantage of non-topological data. Many software packages such as ArcGIS, MapInfo uses the .shp file format. I have used this one, so it is very helpful and user friendly for us. So shapefile, what is shapefile? Shapefile comprises points. A pair of XY coordinate means their location information, lines, series of points, and polygons, series of lines. There are no files to describe the spatial relationship between geometric objects, and polygon boundaries have duplicate in shapefile. Means shapefile is store the data in three types of format: for point, lines, and polygons as the vector data model. So, and there is no any spatial relationship between the geometry objects or data. So this is an example of non-topological data structure. And polygon boundaries may have duplicate in shapefile. As we have seen, the common line are stored in twice in the database. So shapefile is a data format or store the data real world in the GIS application. Now this is the non-topological data structure. As we have studied two types of data structure. First one was the raster data structure. Second one was the vector data structure. And vector data structure was again classified as topological and non-topological data structure. Now these data, as we know, GIS can manage and store a huge amount of spatial data structure. So for storing that data, we have to manage and store that data in a specific manner, so we can retrieve that data for the processing and analysis purpose. So for that purpose, we have to make a management system that is known as the DBMS, database management system. So now we have study about this. As real world entities or objects can be stored in computer world, which are simple or well organized list. So the data record in a file contains all appropriate information for each entity. Means if we store the data in the DBMS, then what is the advantage of? First one is the it can store the data in proper manner with a huge quantity of the spatial data. And after storing that data, if we have to retrieve that data for the analysis purpose, then it make us efficient storing and retrieving the data to model logically the real world features. So there are many different types of DBMS formats like hierarchical, network, relational, multi-dimensional, and object-based, which are used nowadays in the GIS. So there is only purpose that we have to easily retrieve the data for the analysis in GIS application. So as we know, real world entities are represented in the some data format like raster and vector data, and that data are stored in the computer. So for recording the data, that data doesn't have to lose any information, or it must have logical relationship with each other. So the data records may be of same or variable length. As we know, data may be point, line, or polygon. It may be small length and it may be have large length. So there are same length or variable length data. Spatial databases contains many files with data on related aspects of the same entities or other connected or linked together. Means DBMS are useful for both type of data structure, topological or non-topological structure. Means it may have some connected or linked between spatial relationship between the data, or it may not have. As real world has many types of data and huge amount of spatial data, so we have to ensure that the data doesn't have to lose any information and are stored in a proper manner, so we can easily retrieve the data from the database or storage. And storage must be efficient also. So this is the advantage of the DBMS, a software package designed to facilitate creation and maintenance of computerized database, which is called as the database management system. So there is a software package which create and maintain the computerized database. Means any computer or GIS application has some database, and that maintenance and facilitation creation, means that maintenance is the format of database management system, which is very useful for storing the huge amount of data. There are many methods for efficiently storing and retrieving the data. So this is the important point, that many methods for efficiently storing and retrieving the data and to model logically, means logic must be same, the real world features. If there is a pole, then it should be pole in attribute data. It may be represented by point, but their feature and characteristic must be same, so they are logically with the respect to the real world feature would be same in the database management system. So there are many types of DBMS: hierarchical, network, relational, multidimensional, and object-based, that are nowadays used in the GIS application. GIS. The fundamental objective of the DBMS. So what is the basic purpose of DBMS is to make data quickly available to a multitude of the user. Means we can easily retrieve the data from that storage purpose. As we store the data, many data are stored in the database, so they are stored in proper manner, so we can easily retrieve that data for the analysis. So this is the main fundamental objective of the DBMS, to make data quickly available to a multitude of the users. And there are mainly primary three facets of the database integrity. Means they protecting the existing of the database against deletion or corruption. Means DBMS also ensure that the data stored in that database should not be deleted or corrupt with any error. And second one is the maintaining the quality of database to facilitate the addition, removal and updating if necessary. Means we can easily add, remove or update any data, and there must be same quality of the database. Last one is the ensuring the privacy of the database. So DBMS has three primary facets of the database integrity. What is database? Database is the collection of information that is organized in such a way that it can easily and rapidly be accessed, managed and updated. Means any huge amount of data should be stored in such a way that in an proper organized manner, so that we can easily retrieve that data for the accessing and managing and any update if necessary. So that is the fundamental root of the database. A database is an integrated collection of data records, files and other database objects. Means data collection is the format of the database. There are many types of DBMS, ranging from small system that run on personal computer to huge system that run on mainframes. As we know, DBMS may be of many types, such as for the small computers like personal computers and huge system also, because every computer, we can say every computer needs a database management system, because they store and manage huge amount of data. So for storing in a proper manner, we need a DBMS. So a DBMS is a data manager which manages the data in databases. Means managing the database. Database is the collection of data, and that database, managing the database is known as is the DBMS, database management system. Like for personal computer, there is an DBMS like Microsoft Access, which is for the small group user DBMS. And the set of rules for constructing query is known as query language. Means we can run some operations like query on the DBMS or database. So that language is the query language. And for the DBMS, different DBMS support different query language. So semi-standard query language is an example of structured query language, SQL. We have already listened about it. Structured query language that are useful, or a language to DBMS for any query. As we have studied about types of DBMS, such as relational, hierarchical, object-based. So some are the example of relational database management system: Microsoft MapPoint, IBM's Spatial Data Blade, Oracle Spatial. These are the famous database management system, and these types are the example of relational database management system, which having high level programming interface which can be linked to access and manage the spatial data. So these relational database management system has the high level programming interface which link the data, spatial data, to access and manage the data. As we know, DBMS store huge amount of data. So some GIS utilize the DBMS because the capability to handle the data explicitly. And there are examples of DBMS: hierarchical, network, relational, multidimensional, and object-oriented data structure. Non-spatial data structure database models are often used in the spatial information system. So these are the this is the overview of the DBMS, and we will fully explain means what are the type of DBMS, why it is required, their advantages, disadvantages. So all we have to study this DBMS in unit 3. So what we will study in unit 3? Non-spatial data structure. So in this unit we will study about the data and information. What is data and information? What is information? These are two things. Now after that we will study about the database. How to create a database, relationship perspective of database, types of database, non-spatial data in GIS, what is the significance of these database. So we will all study about in 3.2. After that we will study about the geographic data and geographic information, GIS database, DBMS. Again overview we will take. Now this is the important. This part is very important for the exam purpose. That what are the types of database management system or database models: hierarchical model, network model, relational model, and object oriented model. So these 4 points are very important. After that we will also study about the non-spatial data query like SQL model, as we have taken overview in previous section. After that we will study about the buffering, as we have seen the question in GATE exam about buffer. And after that neighborhood functions. After that we will study in 3.8 map overlay, vector overlay, and raster overlay, and last one is the modeling networks. So we will cover everything of the GATE Geomatics syllabus about the GIS in this unit. Now first one is the data and information, means what is the data and what is the information. As we have interchanged these two terms, but these are very distinct. These have very distinct concepts. As data is defined as a body or facts or figures which have been gathered symmetrically for one or more specific purpose. If we have to understand it in simple language, means data are stored in the database, and it can include like pictures, programs, and many rules. Means it is a broad sense and plural in nature. So data are collected symmetrically for one or more specific purpose, as it may be picture, program, or rules. So for example, it can exist in following forms. It may be linguistic expressions such as name, age, address, date, ownership, symbolic expressions, traffic signs. So these all things are the data. Mathematical expressions, E is equal to mc square, and signals, electromagnetic waves. So these all things may be data which have plural or broad sense. Now we will talk about the information. What is information? As we have studied the data, it can be in any form like linguistic, symbolic, mathematical, signal. But information is the data for type, means it is also a data, but it is in the form that we have to easily process, or we can understand that in a simple way. So after processing the data, we achieve the information. For example, information is defined as the data which have been processed into a form that is meaningful to a recipient and is of perceived value in current or prospective decision making. Means if we want to if we want to get an output, so that data must be processed into a meaningful data, so we can easily decide, or we can easily get the output. So that is the format of the information. So it is data that make information useful for one person, and same information may not be useful to another person. For example, if we have to understand it in simple way, if there are two students of 12th class standard, so first one student have branch of commerce and second one has the branch of science. So the data which are useful for the science student may not be useful for the commerce student, but both commerce and science syllabus are the example of data, and science for the science student is the information, and commerce syllabus for the commerce student is the information. Means what is the useful for that recipient, that is format of the data is the information. Information is only useful to its recipients when it is, means information must be relevant to the recipient. It has intended purpose and an appropriate level of required detail for the decision making. So it must be relevant, reliable, accurate and verifiable, up to date and timely. It should be completed. It should be intelligible, means it should be comprehensible, and it must be consistent, convenient and easy to handle, and adequate protected. So we have to understand the concept of data and information, and what is the difference between them. Now so we have to understand these 2 points, because GIS require information, not data. Means the primary function of an information system is to convert the data into information. So we have to follow this in the decision making process. So for that, GIS system, or because GIS is a geographical information system, we have to understand this thing, geographical information system. So we have to convert data into the information. So for that conversion, that information system has to follow these 4 types of steps. First one is the conversion. In this step, it is the process of transforming data from one format to the another. For example, the transformation may be from one unit of the measurement to the another, like kilometer to centimeter, or from one feature classification to another. So there may be a conversion to convert the data into information. Now second one is the organization. It involves the process of organizing or reorganizing data according to database management rules and procedures, and can be accessed cost effectively. So for making the data to useful information, we may organize that data in a proper manner, so we can retrieve and process that easily. Now another format may be structuring. So it represents the formatting and or reformatting of data so that it can be acceptable to a particular software application or information system. So as we have seen that some softwares have an update, so old data format is not open in that updated version. So we have to structure and make that data in that format, so it should be useful for the recipient. So it is another process to make data into the information. Now last one may be modeling. It includes the statistical analysis and visualization of data that improves users' knowledge base and intelligence in decision making. So all these 4 steps may be taken for the converting data into information. Now we know data not properly collected and organized are a burden rather than an asset to an information user. It means data are not properly collected and not properly managed or organized rather than as compared to the information user. So we have to convert data into the information. This is the simple thing in the GIS application. So in the next lecture we will study about the database, how to create a database. So please like, share and subscribe.